The earthquake. Sudden, unexpected, terrifying. No other force of nature can produce destruction like this. No other force kills so many. When it strikes, there's nowhere to go. We can try to prepare ourselves, but the real thing is deadly. We can only hope we survive the most destructive force on our raging planet. Earthquakes are the most sudden, unexpected, and destructive force of nature. They strike without warning. The ground starts to shake, and there is simply no way of knowing when it will stop. It might be a small tremor or a huge, once-in-a-lifetime quake. Either way, you cannot escape it. You can only hope you survive.
And it just kept coming, and it kept coming, and it kept coming again. And it was like riding a roller coaster. It was really a rocking and rolling. I just, in my wildest imagination, had no comprehension that Mother Nature could be that destructive and just, you know.
If there is one thing in life we take for granted, it is the earth beneath our feet.
I looked down and the crack just suddenly opened up, and it just was so quick. It was just like a rifle shot. It just, boom, it was open.
When the earth moves, when the world around us literally collapses, the terror is absolute. No other force of nature can cause so much damage in so little time. In this century alone, earthquakes have killed more than 2 million people. Yet in total, the earth shook violently for less than 1 hour. Earthquakes are very common. Around the world, there are up to 1 million a year, but most of them are too weak to be felt. In an average year, there may be a few hundred quakes which cause minor damage, and between 1 and 20 major earthquakes. This is central Italy, October 1997. An earthquake struck a wide region in the middle of the night. It caused damage to many buildings and 6 deaths. Ten hours later, the first of several aftershocks hit. It was much stronger than the first tremor. Hundreds of houses collapsed. In one village, the whole population was made homeless.
Sì, non c'è stato mai. Qualche spozzetta così, ma poca roba. Forte così non c'è stato mai.
Quelle della notte uno non si rendeva conto, perché dormivi e sentivi che ti urlava la casa e non ti rendevi conto. Quello del giorno e vedevi quelle case che sembrava che ti venissero addosso.
The aftershock brought tragedy to the 700-year-old Basilica of St. Francis in Assisi. After the original quake, a group of monks and others were examining the beautiful frescoes on the walls and ceiling for signs of damage. While they were working, the aftershock struck. Part of the ceiling collapsed on them, killing 4 people. Without people, earthquakes would pose no threat. In an uninhabited region, even a major tremor may leave no sign that it ever happened. But this is a crowded planet. Many regions prone to earthquakes are also full of people. Urban areas are becoming larger and more complex. Cities are growing all the time. A large earthquake in a crowded urban area could kill more people in a few seconds than any other form of natural disaster. Today, an estimated 600 million people live in areas where damaging earthquakes occur. They live with the risk that their homes and lives may be destroyed at any moment. It's a risk that becomes just part of life. This is the signature of an earthquake, recorded by an ultra-sensitive seismograph buried deep in the ground. Any quake anywhere causes the whole Earth to vibrate. This one could be happening hundreds or thousands of miles away, even on the other side of the planet. At the National Earthquake Information Center in Colorado, every significant tremor on Earth is recorded. Data is beamed in from seismographs all over the world. The center analyzes the information and alerts authorities about the magnitude and scale of each quake. When an earthquake occurs, the first waves to arrive are the fast pressure, or P waves. Alarms go off all over the building to alert the scientists. The instruments register the shock waves from different parts of the world.
Here's a P arrival here. P arrival here, P here. See all this in New Hampshire. There's a P there. This earthquake, I think, is not in the United States, but it's a pretty big quake. Probably, maybe south. This is just coming in. We don't even know where it is yet. This is an earthquake. This is the type of thing that just happened. We talk about prediction. We didn't predict this. We cannot predict. We cannot forecast. The earthquake is occurring.
The computers then pinpoint the exact location and magnitude of the quake within minutes.
We got so far as Panama or Colombia border.
This information is then sent automatically to key personnel via their pagers.
Just a moment, I'll get it for you. 7.4 degrees north. Origin time is 17 hours, 25 minutes, and 00 seconds.
The first seismic detector was invented almost 2,000 years ago by a Chinese mathematician. He built a device with metal balls and dragons' mouths. A pendulum in the instrument moved when it registered a quake, and the balls fell out into the waiting frogs' mouths below. The Chinese were unique. Other cultures relied on religion and mythology to explain earthquakes. The early Japanese spoke of a giant catfish that fought with a god. The god won and stood in triumph on the great fish's head. From time to time, the catfish thrashed around, and the drumming of its huge tail shook the ground. Modern science gives us a more rational explanation, but it too shows us just how small we really are. Earthquakes happen because on a vast, slow scale, the entire surface of the planet is in motion. The Earth's crust is divided into broad pieces called tectonic plates, floating above the liquid mantle hundreds of miles below. These tectonic plates are constantly moving, driven by convection currents in the mantle. The movement is incredibly slow, about ½ an inch per year, or just about the speed that fingernails grow. In some parts of the world, the plates collide. One plate slides under or past the other. The immense forces push up the crust, forming mountains and volcanoes. "95% of all earthquakes happen along the boundaries between tectonic plates. So it's not surprising that one of the largest earthquakes in recent years occurred where the Pacific Plate is moving past the continental American plate. It was Alaska in March 1964. The earthquake struck along a fault line 500 miles long. Shaking was felt for almost 7 minutes, an incredibly long time for an earthquake. The town of Anchorage was hardest hit. The force of the quake was so great that the ground itself was torn up for miles. In places, the land sank 50 feet. The amount of energy released was the equivalent of 12,000 Hiroshima-sized atomic bombs. Fortunately, the area was sparsely populated, but still, 115 people were killed. Southern China also lies at the edge of the same Pacific Plate. It was hit by a much weaker earthquake in 1976, but this quake struck near the surface and hit a densely populated region with many poorly constructed buildings. More than 250,000 people died. Another 800,000 were injured, and several million were made homeless. Moderate tremors at shallow depths usually cause much more damage than larger, deeper quakes, because the shaking is transmitted to the surface quickly and without much loss of energy. Wherever they happen, the causes of earthquakes are the same. When two tectonic plates move against each other, there is enormous friction along the line between them, known as a fault. If the rocks on either side of the fault become locked together, huge amounts of energy build up as they strain to get past each other. Time passes, a few years, or maybe hundreds, but eventually the plate movement breaks the grip between the two sides of the fault. The plates move, suddenly and rapidly. On the surface, there is a violent rippling of the ground. An earthquake has occurred. Perhaps the most famous example of this type of fault is the San Andreas Fault in California. Everywhere along it, there is evidence that the earth is moving. This is Hollister, California. Here in the leafy suburbs, a major force of nature is revealed by a bend in the sidewalk. It may not look much, but this curved wall was straight only 5 years ago. The fault passes right under the wall and the sidewalk. One side is moved relative to the other. Placing a building across the fault is asking for trouble, but that's what happened with this winemaking factory. Here in the farmland outside Hollister, the line of the San Andreas Fault is less obvious, but still visible along the line of trees at the bottom of this valley. This is rich grape-growing country with a local vineyard. Unfortunately, the people who built the winery had no idea that the flat land at the bottom of the valley hit a major tectonic fault. They built the winery right across the fault. The building completely straddles it. So, in addition to making fine wine, the owner has to deal with the fact that the building is slowly being torn apart, one half traveling in the opposite direction to the other. Structural repairs help temporarily, but the future is bleak. If there is a major earthquake along the San Andreas Fault, the building stands little chance. October 1989, another part of the San Andreas Fault, this time under the Bay Area of San Francisco. The Loma Prieta earthquake was the biggest tremor to hit the region since the Great Earthquake of 1906. San Francisco lives in constant fear of earthquakes. This time the city was lucky. 63 people died. But it could have been far worse. Several miles of roadways and hundreds of buildings collapsed or were damaged beyond repair. This quake was less severe than it might have been. Some scientists had forecast that the stresses in the fault would build up to one giant earthquake. Instead, the fault may be releasing its stored energy in a series of smaller tremors. One thing is certain, though. The San Andreas is a highly active fault, and violent tremors could happen at any time. Along the San Andreas Fault, the two plates are moving laterally. But the hills around Los Angeles hide another danger: vertical faults, where one plate is pushing up against another. Seismologist Lucy Jones is someone who understands the potential for disaster in Los Angeles.
Los Angeles is a major world city sitting at the conjunction of two major fault systems. We have the strike-slip faults of the San Andreas Fault coming up from the southeast into Los Angeles, and we have the thrust faulting systems of the transverse ranges that create these mountains that we're standing on. And in the transverse ranges, one set of rocks are being pushed up and over the set below it.
In January 1994, one of these faults did slip and caused the Northridge earthquake.
Hello, is anybody there?
No one even knew this fault existed.
This is all the first floor underneath here. This is the second floor right here.
Is he underneath us?
Yeah. Is anybody in there? Okay. Here, hold on. Just keep on going through.
There were only 72 deaths, but the Northridge quake injured 7,000 people and left another 20,000 homes